You open your phone, tap an app icon, and boom, you're instantly connected to the world. It honestly feels a bit like magic, doesn't it? But behind that perfectly smooth glass screen, an average app is running on hundreds of thousands of lines of code. Have you ever actually wondered how your favorite app gets made? Well, today we are demystifying the whole world of software creation, and we're going to turn that magic right back into logic.
Okay, let's dive into this. We are going to look at coding and app development not as some impossible, arcane secret, but really as a builder's blueprint. Because just like constructing a house, building software requires the right raw materials, a solid architectural plan, and of course, the proper tools. By the end of our time together in this explainer, you're going to see exactly how these digital structures are built from the ground up. Here's a quick look at our syllabus for this crash course. We'll start with software basics, explore web and mobile platforms, map out the development lifecycle, open up the developer's toolkit, look at UI and security, and then finally chart out how you can jumpstart your tech career. All right, Section 1, Welcome to Software Development. This is where we lay our foundation. At its core, software development is all about designing, developing, testing, and maintaining software. And that software pretty much falls into three main buckets. You've got system software, which actually runs the device itself. Then there's application software. Those are the programs you directly interact with every day. And finally, embedded software, which lives inside specific devices, like your smart fridge or the computer in your car. Now, to build any of these, you need the raw materials, programming basics. Think of these as the absolute bricks and mortar of construction. Use variables and data types to hold your information, operators to change it, and things like if-else statements and loops to give your structure actual logic. It's literally telling the program exactly what to do and when to repeat it. Now, what's really interesting about this is how you have a massive, diverse menu of programming languages to choose from. You don't just pick one at random, right? You choose the specific material for the specific structure you're building. For example, JavaScript is basically essential if you're making websites interactive. Python? That's beloved for AI and data. Java is incredibly robust for those massive enterprise systems, and C++ gives you the raw, unadulterated performance you need for high-speed gaming. Moving right along to Section 2, Web and Mobile Platforms. Because now that we have our raw materials, we need to decide exactly which neighborhood we're building in. So if we decide to build for the web, we're dealing with a full ecosystem, and it's divided into three parts: the front end, the back end, and the database. The front end is the part you, the user, actually see and click on. It's the paint, the windows, the layout of the house, and that's built using HTML, CSS, and JavaScript. But behind the walls, making the plumbing and electricity actually function, is the back end. Technologies like Node.js, Python, and Java run all the hidden logic of the website. And finally, we have databases, using SQL or NoSQL. Think of these as the basement storage, securely keeping all your user data, your passwords, and your content totally organized and ready to grab at a moment's notice. But what if you decide to build for phones instead of the web? Well, then you enter the world of mobile app development. And here you have two distinct paths. You can build native apps tailored specifically for one operating system, so that's using Java or Kotlin for Android or Swift for iOS. Or, and this is a real game changer, you can use cross-platform frameworks like Flutter or React Native. These are incredibly efficient because they let you write your code just once and then deploy that exact same code to both Android and iOS. For startups and businesses, honestly, this efficiency translates to saving massive amounts of time and literally millions of dollars. Okay, Section 3, the software development lifecycle. Because you can't just start throwing digital bricks together and hope a house stands up. You need a professional blueprint. This brilliantly illustrates the SDLC, the standard pipeline for building reliable software at scale. It shows how software moves methodically from just an abstract idea to a living, breathing product. First up, you gather the requirements, like what does this app actually need to do? Next is design, where you plan out the architecture. Then comes development, where the actual typing and coding happens. Once it's coded, it goes through rigorous testing. After it passes, you move to deployment to make it live for users. And finally, maintenance, because let's face it, software always needs updating and tweaking over time.
Let's actually look a bit closer at those last crucial steps. Testing isn't just giving the app a quick once-over. It happens in intensive, multi-layered stages. You have unit testing for individual little pieces of code, integration testing to ensure those pieces play nicely together, system testing for the entire application, and UAT, user acceptance testing, which basically just makes sure it actually solves the user's real-world problem. Once testing is done, we hit deployment. This is the big moment where your app goes live to the public. You set up your domain, your server, and you host your application on these massive, powerful cloud computing platforms like AWS or Azure.
Which brings us to Section 4,
The developer's toolkit. Every builder needs their digital workshop, right?
First and foremost here is version control. We're talking about tools like Git and GitHub. Imagine building a house, realizing you completely messed up the second floor, and being able to just instantly rewind time to yesterday's pristine setup. That is exactly what version control does. It's this incredible professional safety net that meticulously tracks and manages every single change made to the code. It allows massive teams to collaborate without constantly overriding each other's work.
Next up in the toolkit are APIs. An API is essentially an interface used for communication between completely different software systems. Think about when you buy something on an app. That app doesn't have its own massive global banking infrastructure built in. No way. Instead, it uses a payment integration API to securely talk to a bank system, process your payment, and instantly send the approval back. APIs are basically the digital messengers that make the modern web interconnected. Without them, honestly, the internet as we know it would just break.
Rounding out the daily tool belt, VS Code is the actual text editor where developers spend most of their days typing away. Postman is the industry standard to test all those APIs we just talked about, and Chrome DevTools lets developers tweak websites live right inside their web browser. These are quite literally the hammers, drills, and nails of the digital trade.
All right, Section 5, UI, UX, and security. A building isn't finished until it actually looks good and is totally safe to live in.
So, UI and UX stand for user interface and user experience. Think of this as the interior design of your app. It absolutely demands user-friendly design, super simple navigation, and visual consistency so the user just intuitively knows where to click without thinking. But, and this is absolutely crucial, beautiful design means absolutely nothing without security. If UI and UX is the interior design, security represents the non-negotiable deadbolts and alarm systems. One single missed vulnerability can expose millions of users to hackers. So setting up bulletproof authentication and data protection is paramount.
Let's move to and see how this builds into Section 6, starting your tech career. Because taking all this knowledge and actually applying it out there in the real world is where the fun really begins. So, the crucial point is that there isn't just one single job title waiting for you. The tech industry offers so many unique paths. You could be a classic web or mobile developer, writing that core code. You could specialize in QA or quality assurance, becoming the testing expert who ensures the software is completely flawless. Or you could go into DevOps, focusing entirely on the deployment, hosting, and operational side of the software lifecycle.
Whichever path you end up taking, standing out requires following best practices. True professionals write clean code that other people can easily read. They stick to strict naming standards, and they heavily prioritize testing. But above all else, they commit to continuous learning. Technology evolves incredibly fast, and the true mark of a great builder is the willingness to always be learning new techniques and picking up new tools.
So, how do you take that very first step today? By doing practical exercises. Start small. Try building a simple to-do list app where you can add, delete, and check off tasks. Or try coding a basic calculator, a static one-page website, or even just a secure login form. Don't try to build the next massive global social media platform on day one. These small, actionable mini-projects are exactly how every single professional developer on Earth got their start.
We've laid out the raw materials, the architectural plans, the toolkits, and the career paths. The blueprint is fully in your hands now. The only question left is, what will you build first?